Okay, guys, let's take a look at your problems from last night. It says problem number one was a vocabulary question, right? Just to see if you guys paid attention to what what the vocabulary said. It's only one word in the vocabulary for the lesson. A figure made up of triangles, squares, rectangles, semicircles, and other two-dimensional figures. Yes, that is a composite figure, right? So that is answer B. Wouldn't expect many mistakes there, right? But let's get into this next problem. And I know that this was a tough problem for a lot of people. Every year when I give this problem on an assessment, test, or quiz, it's always challenging for students. And there wasn't a problem like this in the lesson, but I did give you guys a hint in the directions. Right? It says to find the area of the figure, you must find the area of the entire triangle, including the rectangular section, then subtract the rectangular section from the area you found for the triangle. Right? So let's take a look at what that's going to mean. Right? First thing you want to do is to find the area of this entire triangle. Right? So we're talking about this whole triangular shape here. But in order to do that, we need the base of the triangle, we need the height of the triangle. Okay? Well, let's talk about the base of the triangle. We know that from here to here is 63. We know that from here to here is 31. Right? So we need the sum of those segments, right? The sum of those segments, which would be 31 and 63, what's that, 94? Right? So 94 is going to be the base of the triangle, right? 94 inches is the length from here, right, to here. There's your 94 inches. But we also need the height of the triangle, right, which is the distance from here to here, right? We need that. We know that from here to here is 63. We know that this segment is 63. So 63 plus 63, right, means that this distance here is 63 plus 63, or 126 inches. So you had to do that math before you did anything else, right? You had to find, the lengths of those segments. So let's start with the area of the triangle. Right? So we find the area of the triangle. I'm just going to abbreviate it this way. Area of the triangle is equal to 1/2 base times height. Right? Same formula we're used to using. So the area is going to be equal to 1/2. Your base is 94. Your height is 126. So 94 times 126. Right, you can go ahead and use your calculators for that. Right, but that's going to be 94 times 126. Then we have to divide that by 2, and we wind up with 5,922, and those are square inches. That's just the area of the triangle. Well, let me fill this in here so we can see exactly what we're talking about here. We just found this area. We found the area of that entire triangular section, right? That's what we just found, right? And that is your 5,922. The next thing we have to do is to find, right, this area in here, right? We need to find the area of that rectangle. All right, so we're going to find the area of that rectangle next. Now the area of the rectangle, right, obviously that's much easier, right, because it is a rectangle. Right, so let's go ahead and find that. Right, so the area of the rectangle, I don't want to use that pen. Let's undo that. Right, it should be here, and right, so I need the area of the rectangle. It's going to be length times width. So the area is going to be equal to, the length is 31, the width is 62. So that's going to be 31 times 62. So the area is going to be equal to, let's do the 31 times 62. 31 times 62. 31 times 62. We wind up with 1,922. Right, and those are also squared inches. Now we want to find the area of that original figure. So if we take away this area here, right, if I take away the area of that red rectangle, look what's left. right, the area of the original figure we started with. So we're going to have to subtract the two areas. So we're going to take 5,922. We have to subtract 1,922. And when we get that, we wind up with, let's see, we get 0, 0, 9, and 9 minus 9 is 0, right? We get 4,000, right? And that's not one of our answers, right? So let's see, something is not correct here. So let me just double check, right? Make sure that our numbers are correct. Let's see. Here's one mistake right here, right? This is 63 and 62. Right, so let's go back and fix that. Right, 63 and 62, that's 125. Right, let me just double check, see if I made any other mistakes. This is going to be, let's see, 94, so that's right. So that should be 94, clear. 94 times 125, and we're going to divide that by 2. That's 5,875. So let's fix that. All right, so that's 5,875, and then we're going to subtract that. So let's redo that. Redo that. 5,875, and let's subtract minus the 1,922, and we get 3,953. Right, and that is answer A. Right, and those are squared inches. Right, and guys, that's, you know, a lesson right there where, you know, if we get an answer that doesn't match up, right, with one of our answers, go back and see if you can find a mistake. Right, you know, I added 63 and 62 with my bad eyesight. That looked like 63 initially, but you know, this is what we do. We try to find our mistakes, we correct them, and we get answer A for problem number 2. Alright, let's go to the next one. Let's see, we want to find the area of the composite figure. Looks like we put the two semicircles together to form a circle. Some call that area 1. And the rectangle we're going to call area 2. So let's start with area 1. Area 1 is two semicircles, so that's going to be pi times r squared, because when we put two semicircles together, that's going to create a circle. So area 1 is going to be equal to, let's use 3.14 for pi, times the radius. Well, if the diameter is 18, the radius here is going to be 9, so that's going to be times 9 squared. And let's do that. 9 squared is 81 times 3.14, wind up with 254, area 1, 254.34. Those are square inches. And then let's do area 2. Area 2 is a rectangle, so that's going to be L times W. Area 2 is going to be equal to, what's that, 4.5 times 18? 4.5 times 18, so area 2 is going to be equal to, let's do that, 4.5 times 18, wound up with 81. Those are square inches. Now we need that total area, so we're going to have to add these two numbers, right? So we need the total area, so that's going to be 254.34 plus the 81, 254.34 plus 81, and we wind up with 335, right, when I add those together. So we have total area is going to be equal to A1 plus A2, right, so that's going to be 254.34 plus 81, that's going to be 335.34. Those are square feet, and that looks like that's going to be answer C. Alright, next one. We want to find the area of the square, then subtract the area of the semicircle to find the area of the figure. So we're looking for this area in here, right? That's what we're looking for, this stuff, right? We're looking for that area in here. And to find that area, we're going to have to find the area of the square and subtract the area of the semicircle. So let's do that first. The area of the square is going to be equal to the length of the side squared. So that's going to be 30 squared. And 30 squared area is going to be equal to 900. Those are square feet. Then we need the area of the semicircle, right? The area of the semicircle. That's going to be equal to pi times the radius squared, but we need half of that. So that's going to be 3.14 times our radius. Well, what's the radius? The radius is this distance here, which is going to be half of 30, so that's going to be 15. And we're squaring that, but because it's a semicircle, we're going to have to divide that by 2. So with your calculators, make sure you do the 15 times 15 first, which is 225. Then you multiply that by 3.14, and then you want to divide that by 2, and we wind up with 353.25. It's going to be 353.25. Those are square feet for that area. So we need the sum, right, the total area. We want to add the 900 plus the 353, and that's where we get 1,253, right, 0.25. Those are square feet, and that's going to be answer C. Okay? All right, our next example. Let's see what we have here. Different ways we could do this. Let's see. How do I want to do this? How about we do this? Right, a lot of different ways we could do this. We could use the trapezoid, but I'm going to pretend we don't know the formula for the area of the trapezoid. So I'm going to split this into 2 areas. Let's call this area 1. Area 1 is this whole rectangle here. It's going to be area 1. And area 2 is going to be the 2 triangles. Right? Now, area 2, when you put 2 triangles together, that's going to make a rectangle. So that's actually going to make the calculations pretty simple. So let's start with area 1. All right, area 1 is going to be equal to 11, or length times width. Area 1 is going to be equal to 11 times, what's the width here? Well, this is 20, and this is 6. So that looks like that's going to be 26. So area 1 is going to be equal to, what's that, 286? 26 times 11. Yep, that's 286. Those are square centimeters. Okay, now let's find area 2. Area 2 is a triangle, but there's 2 of them. So if we do 1/2 base times height, but then there's 2 of them, right? They cancel out. So area 2 is simply base times height. So area 2 is going to be equal to, let's see, well, what's the base? Let's see. Well, if this whole thing is 41, and from here to here is 11, so if I take this 11 away, right, that leaves 30, and if I have to split that 30 by 2, that's going to be 15 and 15. So let me just explain that a bit. This whole thing is 41, and this is 11, so 15 plus 40, 15 plus 11 plus 15, that's going to be equal to this 41 here. So the base of the triangle is going to be 15. The height of the triangle is going to be 20. So area 2 is going to be equal to 15 times 20. That's going to be 300 square centimeters. We need the total area, so we're going to have to add. So that's 286 plus 300 should be 586 square centimeters, and that's answer A. Right, that should be answer A. Okay. Now, These other figures, right, we just want to be able to do this using the grid paper, and there's different ways we could split this up, right? But it's really easy just to count the squares, right? So this first one we'll do by counting the squares. Let's start with the whole squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, right? So we have 36 full squares, right? So there's 36. But then I have my half squares, right? These are half, so we have 36, right? So if I take 36 and I have, right, two halves, that makes a whole, so that's 37. That's 38, and then another half. So the area is going to be equal to 38.5. Right, that's 38.5 square units. Now that's if we're counting the squares, right? But if I take that same problem, I'm going to clone it, so I'm going to move this over here. Or if I take that same problem and instead of counting squares, I'm going to split it into pieces. So let's do this. Let's do a lot of different ways to do this. So let's take away, let's do this here, and then do this here, and then what do we have here? Let's do let's see. Alright, let's do, okay, so what do we have? If I do this here, right, I know that's 9, and then if I do, let's see, this here, right, that's going to be what, 4 by 4, that's 16, 3, 4, and then I know this is half of 4, so that's 2. This is half of 9, that's 4.5. Right, let's see if we get the same answer if we add all these numbers together. 3 plus 16 is 19. 19 and 2 is 21. 21 and 4 is 25. 25 and 9 is 34. 34 and 4.5. Right, you're still getting an area of 38.5. Right, so those are your options. There are different ways that you could do it. All right, so let's just take a look at the next few problems. I'm not going to do the next 3 problems, the same way. I'll just alternate different strategies, right? So this one's probably pretty easy to do this way, right? Because it's pretty simple. So let's split it up this way. 3, 6, 9. That's 12. 3, 6, 9, 12, 15, 18. That's 21. Half of 9 is 4.5. So this is going to be what? Let's see. We have 21 and 12, that's what, 33, 33 and 4 is what, 37.5. Hopefully I did that correctly. Let's look at this next one. Here, we'll do it this way, and then I'm going to do 3, 6, 9, 12, 15, that's 18, and then this is what, 1/2 of, what's that, 3, 6, 9, 12, 15, 1/2 of 18, which is 9. Oops, 18 and 9. Let's undo that. Computer's going a little crazy here. Right, 18 and 9. That's going to be an area of 27 units. Alright, and then we have this crazy one. Wow. Let's do, let's see, how do we want to split this up? This one's interesting. Let's do, I don't know, do this one here. That's half of 9, right? Because there's 3, 6, 9. Half of 9 is 4.5. Then we can do, right, this one here is another half of 9. So that's 4.5. And then we could just fill in the rest of this, right? This is, actually, I probably should have done it this way, but that's okay. We'll do it this way. 5, 10, 15, that's 20. 3 and 3 is 6. That's 6. So we have 6 and 6 is 12, and 20 is 32. 32, what's that? 32 and 9. That should be an area of 41 square units. Alright. Okay. Back to some problems without the grid paper. Want to find the area of the figure. Right? So let's call this area 1, area 2. Area 1 is going to be equal to length times width. Area 1 is going to be equal to 5 times 1. So area 1 is going to be equal to 5 square units. Area 2 is 10 times 3. Area 2 is going to be equal to 10 times 3. So area 2 is going to be 30 square units. So 35 and 30. So we get 35 square centimeters for the area for number 10. Alright, let's go to this next one here. Let's call that area 1 and area 2. Area 1 is a triangle, so that's 1/2 base times height. Area 1 is going to be equal to 1/2. Well, what's the base of this triangle? Well, if this whole thing is 5 and this is 2, this has to be 3 because 3 plus 2 would give me the 5 units, right? 3 plus 2 gives me 5. So I know that that's going to be 3. So it's going to be 1/2. Oops. I don't like that being the same color here, so let's erase that. Right, so that's going to be, right, that's going to be 3 inches. So area 1 is going to be 1/2, 3 times 4. 3 times 4 is 12. 1/2 of that is 6. So that's 6 square inches for area 1. Area 2 is going to be 6 times 5. Area 2 is going to be 6 times 5. So area 2 is going to be equal to 30 square inches. So your total area is going to be 36 square inches. Alright, what do we got? Thought this problem was pretty neat. Haven't seen any like this before. The mouse hole is made up of a semicircle and a rectangle. Okay, so we have semicircle and rectangle. Its area is 38.31 square inches. What is the height? H. Use 3.144 pi. Okay. Well, let's see. How can we do this? Well, let's start with the area of the semicircle, right? That's the key, I think. So we want to start by finding this area here. And how are we going to do that? Well, let's see. We know that if this is 6, we know that the radius then is going to be 3 inches. Alright, so let's do that. The area of the semicircle is going to be pi times r squared, but because it's a semicircle we take half. So area is going to be equal to 3.14 times the radius is 3, which is square it, but then we need half of that. So with your calculator, right, you're going to have to do 3 squared, which is 9, times the 3.14. Then we have to divide that by 2, and we get the area of the semicircular part of the mouse hole is going to be 14.13. Those are square inches. Now, why is that important? Well, that's important because, right, we're looking for h. We're looking for that height. Well, we know that this is 3, but then I need this distance from here to here. Right? So how am I going to find that distance? Well, if I know the area of the semicircle is 14.13 and the whole area is 38.13, I subtract that. 38.13 minus the 14.13, and we wind up with, what's that, 0, 0, 4, and 2, right? So we get 24 for the area of the rectangle. Well, we know that the area of a rectangle is base times height, right? So the area of a rectangle is length times width, or base times height. We know that the area of the rectangle is 24. Well, how do I know that it's 24? Well, because we know that the total area of the mouse hole is 38.13. I know that I found the semicircular part of that is 14.13. So by subtracting the 14.13, By subtracting the 14.13 from 38.13, we get 24 left for the area of the rectangular part of the mouse hole. 6 times 4 would be 24, so I know that this is 4. So what's the height of the mouse hole? The height of the mouse hole is going to be 4 plus 3. The height of the mouse hole then is going to be 7 inches, right? Because this is 4 inches. From here to here is 3 inches. From here to here is 4 inches. So we get 7 inches for the height of the mouse hole. I thought that was a pretty neat problem. All right. Back to some of the traditional problems. We want to find the area of the shaded region. Let's call that area 1. Call the triangle area 2, and let's call the rectangle area 3. Right. So we have to find 3 different areas here. Let's go with area 1. Area 1 is going to be pi times r squared, but we have to take half of that because it's a semicircle. So area 1 is going to be equal to 3.14 times your radius. Well, if your diameter is 12, your radius is 6. We're squaring that, but then we're dividing that by 2. All right, so let's do 6 squared is 36 times 3.14. We divide that by 2 and we get 56.52. Area 1 is going to be 56.52. Those are square centimeters for area 1. Area 2 is 2 triangles, so that's 2 times 1/2 base times height. They cancel, so area 2 is just going to be the base of the triangle times the height of the triangle. Area 2 is going to be equal to, what's the base of the triangle? Well, let's see. If this whole thing is 22, and from here to here is 12, 12 take away 22 is 10, that means this has to be 5 and this has to be 5, because 5 plus 12 plus 5 gives you 22, which is the length of that entire segment. So base times height, that's going to be 5 times 13. So area 2 is going to be equal to, what's that, 65 square centimeters. Area 3 is a rectangle. And what's the rectangle? That looks like that's going to be 12. Actually, it's a square because it's 12 by 12. So area 3 is going to be 12 times 12. So area 3 is going to be 144 centimeters squared. So then we need the total area. So that's going to be 65 plus 56.52 plus the 144, right? So we're going to add that together. That's 2, that's 5, that's a decimal point. That's 15, 5 carry the 1. That's 1 and 6 is 7 and 5 is 12. 12 and 4 is 16, carry the 1. So we get 265.52. Those are square centimeters for the area of that figure. Problem 13. All right, a lot of work there. All right, this next one's rather easy, but we're looking for the area and the perimeter. So let's start with the perimeter. That's what they're asking first here. So I know this distance, I know this, I know this. What's this little distance here? Well, if this is 8 and this is 5, means that's 3. Well, what's this distance here? If this is 8, if that's 8 and this is 3, this is 5 inches. So the perimeter is going to be the sum of all of these segments. So the perimeter is 8 plus 5 plus 5 plus 3 plus 3 plus 8. So let's do that. The perimeter is going to be equal to 8 plus 8 is 16. 16 and 10 is 26. 26 and another 6. Perimeter is 32 inches, not squared inches. Perimeter is going to be 32 inches. Area, call that area 1, area 2. Area 1 is 8 times 3. Right, so area 1 is going to be 24 square units. Area 2 is 5 times 5. Right, so 5 times 5 is 25 square units. So the total area is 24 and 25. So the area is going to be equal to 24 plus 25. That's going to be 49 square units. So the area is 49 square units, and the perimeter we said was 32 units. Alright, last one. Similar type of problem. We want the perimeter and the area. So let's see, if this is 2 inches, or 2 meters, my bad. Alright, supposed to be an eraser. Let's erase that. Right, that's 2 meters. What's this distance here? Well, this is 5 and this is 1. That means these have to total 4. So that's 2 meters. That's 2 meters. Does look like a square. If that's 1, that's 1. And I think we have enough for the perimeter now. So I'm going to start. Let's start here, I guess. I'll do 2 plus 2 is 4. 4 plus 5 is 9. Plus 2 is 11. Plus 2 is 13. 14. 15. 16. So the perimeter is going to be 16 units. Now for the area, I'm going to do this a little bit differently. I'm going to find the area of this whole rectangle and then subtract the area of the square. So the area of this whole rectangle, I'm going to do that first. That's going to be 2 times 5. So the area of the rectangle is equal to 2 times 5. So the area of the rectangle is equal to 10 square meters. Then I'm going to subtract this little square. I know that that's 1 times 1, which is 1. So take away 1. So we get 9 square meters. Right? 9 square meters for the area of the shaded figure. Alright? Okay, hopefully you guys enjoyed those problems. Tomorrow I'm going to give you guys similar types of problems to practice on your own. If you had any trouble with last night's homework, right, just watch the video, and that'll help you, with some of the problems. And today you'll just get some more practice. So watch the video first, and then get some more practice, and do your best.